Hey guys, welcome back. So today we're doing LeetCode 1022, sum of root to leaf binary numbers. Also, quick thing, I've put a website link in the description. That's just an extra resource I maintain where I post the daily problem of the day with proper documentation and visual working. So if you like reading and seeing things step by step on your own, you can check that out separately. It's not required for this video, just an extra support thing. Okay, let's understand the problem calmly. We're given a binary tree. Each node contains either 0 or 1. Now, every path from the root to a leaf forms a binary number. And our job is simple. Take each of those binary numbers, convert them into decimal, add all of them, and return the total sum. That's it. So let's imagine a small tree. At the top we have 1, left child is 0, right child is 1, and both of them again have 2 children. Now let's actually walk through it slowly. We start at the root, so first value is 1. Now we go left. So path becomes 1, 0. Go left again. Now it's 1, 0, 0. That's a leaf. So this path forms the binary number 1, 0, 0. Now we go back one step. Instead of left, we try right. So now the path is 1, 0, 1. That's another leaf. Now we go back to root. Take the right side. Root, then 1, then 0. So path becomes 1, 1, 0. Then root, 1, 1. So path becomes 1, 1, 1. So overall, we have 4 binary numbers. 1, 0, 0. 101, 110, 111. Now convert them. 100 is 4, 101 is 5, 110 is 6, 111 is 7. Add them. 4 plus 5 plus 6 plus 7 equals 22. So that's what we need to compute. Now the main thinking part. When we move from parent to child, we are adding one more digit to the binary number. So how do we append a binary digit mathematically? We multiply the current number by 2, then add the new bit. Let's see it clearly. Suppose current number is 2. Binary of 2 is 10. If I append 1, I want 101. So 2 multiplied by 2 is 4. 4 plus 1 is 5. And 5 in binary is 101. So multiplying by 2 shifts everything left. Adding 0 or 1 places the new digit at the end. So at every node, we just do current equals current multiplied by 2 plus node value. That's the entire trick of this problem. Now, small connection. If you've seen array representation of binary tree, you might remember that left child index is 2 times n plus 1, and right child is 2 times n plus 2. Notice that 2 times n pattern. Binary trees naturally follow this doubling idea. Here also, every time we go one level deeper, we double the current value and add 0 or 1. Same concept, just different context. Okay, now how do we visit all root to leaf paths? We use depth-first search, because DFS goes deep into one path completely before coming back. And that's exactly what we want, complete paths. So let's simulate quickly. We start at root with current number 0. At root, value is 1. 0 multiplied by 2 plus 1 gives 1. Now go left. 1 multiplied by 2 plus 0 gives 2. Go left again. 2 multiplied by 2 plus 0 gives 4. This is a leaf, so we return 4. Now backtrack. From that node, try right. 2 multiplied by 2 plus 1 gives 5. Leaf again. Return 5. Now go back to root. Take right branch. 1 multiplied by 2 plus 1 gives 3. Go left. 3 multiplied by 2 plus 0 gives 6. Leaf. Return 6. Go right. 3 multiplied by 2 plus 1 gives 7. Leaf. Return 7. At every non-leaf node, we return left sum plus right sum, so everything adds up as recursion goes back. Finally, we get 22. And notice we never stored the path as a string. We never built something like 100 cap in memory. We directly built the decimal value while moving down, so it's efficient and clean. Time complexity is O of n because we visit each node once. Space complexity depends on tree height. Worst case skewed tree, O of n. Balanced tree, O of log n. And yeah, that's the full idea. Start at 0. At each node, multiply by 2, add node value. If leaf, return the number. Otherwise, return left sum plus right sum. If this explanation actually helped you understand instead of just memorizing, tell me in the comments. Like the video if it made sense, subscribe for daily problem breakdowns, and I'll see you in the next one.